All right, this statement right here says 3 times 2 minus k equals negative 3k plus 2. The first step would be to distribute that 3 right there. That way it's a little bit easier to compare these two expressions. So now you can see I've got negative 3k actually on both sides. And that's usually an indication that there will be either no solution or all solutions. It's an indication that it won't be one solution. So I'm going to add 3k to both sides right here. And that cancels this. And I add 3k over here, and it actually cancels the other variable. So usually when you have a variable in an equation, you're solving to find out what that is. And in this instance, there is no variable to speak of anymore. We've got a statement that says 6 is the same as 2. That doesn't make any sense. So there's no solution. Which one of these has infinitely many solutions? Again, you're looking for the coefficients to be the same. That's the number that's multiplying x. So that happens here. Doesn't happen here, so I don't think this would be it. This would be one solution. And it doesn't happen here. This would also be one solution. It happens again here. So it's either A or D, and you're also looking in this instance, you know how the last one, it said 6 equals 2, and that didn't make sense? We're looking for the constant terms to be the same. And in this instance, 3 and 5 aren't the same, so that would actually be an example of no solution. So it's not that one. And this one, it's a little bit tricky because the numbers aren't in the same order, but they both have a minus sign or a negative sign in front of the 5. So I would say that it's letter D, that's infinite solutions. For this one, it's going to be one solution. We got to figure out what that is. So I'm trying to get x by itself, and when you're doing that, it's always a good idea to start with a constant term, which is this 7 here. I'm going to get rid of that by subtracting 7. Whatever you do to one side of the equal sign, you do to the other. 1 minus 7 is negative 6. And now, again, we're getting x by itself, so I need to get rid of the 3. So I would divide by 3. And finally, x is by itself. X equals negative 2. If I plug that back in to the original equation, it would say 3 times negative 2, which is negative 6. And then we'd still be adding 7. And of course, if I have more positives than negatives, this should equal positive 1, so it makes sense that x would equal negative 2. Right here, a very popular wrong answer that I saw, 4. Right away, we see 16 and we see 4 boxes, so I think our brain is trained to think 4 times 4, but this is actually 32 on the right side, so this needs to be 32. So instead of writing 4, we want to write 8 in each of these boxes. And then I'll make it equal to 32. Over here, you'll notice if I have an x here, so since we don't know what's inside the box, I'm going to say it's x. If I take x on both sides, I'm left with this weird statement of 20 equals 0, which doesn't make sense. So there's no solution here. Whatever I put in the box, the left side's always going to be 20 bigger than the right side. Once again, I would start right here by doing the distributive property. So multiplying everything in parentheses by 4. And then we're trying to isolate for x. So we need to get rid of the 20. 12 minus 20 is negative 8. And we're multiplying 4 by x, so I would divide by 4. And then divide by 4 over here as well. So x is equivalent to negative 2. And if we plug that back in, negative 2 plus 5, think of order of operations, we'd add first if it's in parentheses. That equals 3. Times 4 is 12. All right, I distributed the 3, so it almost looks like infinite solutions again because we have the same thing on both sides of the equal sign, but not quite because of this plus x. And I'm going to call this 1x. If there isn't a coefficient there, you can make it 1. And now if you combine like terms, you're going to notice it's not exactly the same thing on both sides. If the coefficients are different, you're going to get one solution. So in this instance, I took 3x on both sides, and we're left with a statement that now says 6 is the same as x plus 6. Well, what number added to 6 equals 6? If we take 6 on each side, you're going to see that x has to be 0. This last one, if you have an exponent to an exponent, it's always going to be multiplying the exponents, so it'll be 2 to the 16th.